This is Algebra 2, Lesson 1.6, Arithmetic Series. So far in this chapter, we've been talking about sequences. Sequences being lists of numbers. A series is if you're going to take that list of numbers and add them together. So an arithmetic series specifically is if you add the terms of an arithmetic sequence. Sometimes these sequences are pretty short and you probably could just do them by hand. Like for example, if I had the arithmetic sequence 2, 4, 6, 8. Let's just say I have the first 4 terms of that sequence. It's plus 2 every time, right? The series would be add them together. And that's only 4 numbers. I could probably just add them by hand. 2 plus 4 is 6. 6 plus 6 is 12. 12 plus 8 is 20. So the series 2 plus 4 plus 6 plus 8 is 20. But let's say you had a really big series that you were trying to figure out, like add 100 numbers, add 1,000 numbers. You probably don't want to add those all by hand. So we do have a formula that can do a lot of the work for us. We're going to use the capital letter S to represent series or sum. We're going to use a subscript N to represent the number of numbers in the series. We need 3 pieces of information. We need the first number in the list. We need the last number in the list. We need how many numbers are in the list. And at the back we have a divide by 2. So one more time. That is the first number. That is the last number. And that is how many numbers. Okay, first number, last number, how many numbers? So if you only have a couple numbers, sure, it might be easy to add them up by hand. But if you have more numbers, if you don't want to go through 3 plus 6 plus 9 plus 12, let's try this formula out in this example, and then we'll test it against using it if we had just done it by hand, okay? So I'm going to start with the 3 things I need to go into the formula. I need my first number, I need my last number, and I need my number of numbers. So the first number here is 3. The last number here is 30. And then I'm going to just count up how many numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. We're going to plug those 3 values into the formula to get the sum of 10 numbers. I'm going to put a 10 instead of an n because this is 10 numbers. We need the first number in the series, in the sequence, plus the last number in the sequence times how many terms of the sequence are we adding together divided by 2. Okay, so I'm going to use my calculator, but you could always do this by hand. You could do 3 plus 30. I know that's 33. You could do times 10 over 2. I know that's 5, so 33 times 5. But if you have the tools to make sure we don't have any arithmetic errors, why not? I got 165. So I'm going to check this just to make sure, just to show you guys that it does give us the same answer. If we were going to just do this by hand, 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21, 24, 27, 30, right? This is my arithmetic sequence where it's just plus 3, plus 3, plus 3, plus 3 every time. If I added up the first 10 numbers in that list, I get the same answer, 165. So with a couple numbers, it might be easier just to add them up. But when you have large lists, that's where the formula comes in handy. Let's try the next example. Find S12 for the sequence UN equals 12 plus 4N. So here's an instance where I don't know the first number or the second number or the third number or the fourth, fifth, sixth. I don't want to have to figure out every single number. I don't want to plug in a 1, plug in a 2, plug in a 3, plug in a 4. I don't want to generate the whole list. So I'm going to use that formula because I only need to find 2, technically 3 numbers to be able to use this. I need the first number. I need the last number. sorry, those should be u's. I need the first number. I need the last number, which in this case is the 12th number because I got this little 12 here. That means n is 12. Okay? So to get the first number, we're going to substitute 1 into our un equation. So that's going to be 12 plus 4 times 1. 4 times 1 is 4. 4 plus 12 is 16. I'm going to substitute 12 into the n of my un equation. 12 plus 4 times 12. 4 times 12 is 48. Plus 12 is 60. N is 12. So what we're going to do then is use our S formula to get the sum of 12 numbers. I need the first number plus the last number times the number of numbers over 2. You can do this by hand. You can use your order of operations. You can go to your tool, and as long as you type it with the parentheses and everything, it should tell us that if we added 16 plus 20 plus 24 plus 28 plus all the way up to plus 60, we would get 456. Example C. For a fundraiser, Anthony earns $5 for the first mile he runs, $7 for the second mile, $9 for the third mile, and so on. Write an expression to represent his earnings per mile. Okay, so this is actually what we did in the previous lesson where we're going to come up with an explicit formula. So to do that, I need two things, right? To come up with a explicit formula, I need the starting number and I need what it changes by. Okay? So in this one, we know that it has a 5, and then it has a 7, and then it has a 9. So we can always calculate that difference by taking the second number minus the first number. But hopefully that's clear enough that it's just plus 2, plus 2, plus 2. But then we also need to go backwards to get the 0 number, because we know the first number is 5, and the second number is 7, and the third number is 9. If we're going to go backwards to get the 0 number, we need to take our first number and subtract our difference. Going backwards, there would be a 3 in front of this. Okay, so we have our difference. We have our U0. Our UN equals our U0 plus our difference times n. Now that we know that, we can figure out what his 10th answer would be. Now remember, you could still do these recursively if you really, really wanted to, right? There's nothing wrong with hitting enter a bunch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 23. Or, now that we have our explicit rule, we can substitute 10 into our explicit rule, and it jumps us straight to the same answer. So either way, I'm going to record it using the explicit version. We substitute 10 in for n. 2 times 10 is 20. 20 plus 3 is 23. We already saw that on the calculator. So that is technically U10. How much does Anthony earn total for running 10 miles? That is going to be S10. So I wanted to point this out to get the difference between U10 and S10. U10 is the 10th number in this list, right? 5, 7, 9, 11, 13. If you keep adding 2, adding 2, adding 2, U10 is the 10th number in the list. S10 is adding all 10 of those numbers together. Okay, so we have 5 plus 7 plus 9, like I said, plus 11 plus 13 plus 15, all the way up to plus 23. But I'm going to use my SN formula to do that. So I need 3 things. And luckily, we already have most of those things, right? So U1, my first answer is 5. UN, because n is 10, UN is U10. And we have U10 right here. Oh, should have circled that one. 23. Now we can plug those 3 into my S formula. So to get S10, to get the sum of the 10 numbers in this sequence, we need the first number plus the last number times the number of numbers divided by 2. So you can piece by piece that, order of operations it. You can type the whole thing straight in to your calculator, so long as, again, you remember to use your parentheses. Without the parentheses, it's not going to come out right. That is $140 whopping dollars that this kind gentleman raised for his organization. Whew, that is it for these notes. Good luck on the exercises, and please let me know if you have questions.